the podcast where the real world meets the digital world as we explore the intersection of spatial computing and AI. Let's welcome our host, Andrew Ballard. Over to you, AB.
Well, g'day and welcome to Spatial. This is the inaugural episode of a guest interview. Inaugural. Am I going to already question why is the word inaugural? Can you have the word augural? Anyway, it's the first ever guest interview. I'm joined this morning to my right, Helena, there in New Zealand. Good morning. How are you faring?
Yeah, good, thank you. And very welcome to Scott. We're really pleased to have you on.
Yeah. Thank you so much. Yeah, I'm really happy to be here and actually honored to be your very first guest.
The very first. In this country, we'd call you the guinea pig. That's okay. All good. There's nothing to be worried about.
Yeah, we use that phrase too. So.
Oh, excellent. With the two of us having a chat to you, we haven't got the full team. We thought it might be a bit rude to have 5 people asking you questions at the same time. So there's 2 of us here this morning. Loving to have a great chat with you. But look, if you have a few seconds, can you tell us a bit about yourself? A quick bit of your history, but also what you're doing in that part of the world.
Yeah. So I've had a long history in the geospatial field. It's kind of weird how it all just kind of worked out this way. Even when I was a kid, I was a maps guy, always staring at maps. Also, too, I'm always spatially aware. I always want to know what direction I'm facing. There's been times in my life you get out of the subway in New York City and you don't know quite which way you're facing, and it's really disconcerting for me. So, anyways, I have a long history in geospatial. I got my bachelor's at Penn State University. After there, I worked at MapQuest.com for 2 years. Then I went got my master's at University of South Carolina. So I kind of made my way down the East Coast of the U.S. So I did my master's on, I would say at that time, I don't know what you'd call mobile mapping. So this was very, very early stages of GPS-enabled smartphones with a 100.
Yes, this was the prehistory of
the Palm Pilots.
2D mapping. Yes.
Yeah, Palm Pilots and all. So there was 100 by 100 pixel black and white, screen, and I was able to put some imagery on that. So it was kind of cool. It actually worked, and it picked up the GPS location and showed me, based on where I was, it showed me a image that you could kind of make out water bodies and stuff. So it was kind of cool. So anyways, then after that, I got a job at Esri. So when I was getting my master's, I took a programming course, Java at the time. And then that kind of helped me. Also, too, I wrote this application for my master's in Java that helped me get this job at Esri as an applications developer in the DC office. That was a really exciting time working for some really exciting clients there. And then basically after that, I went down the East Coast, and then I came back up the East Coast to my hometown, which is in my alma mater. I was a researcher then at Penn State University, my alma mater, for basically 15 years. And I worked at a research center there called GeoVista Center. We were doing it was really a wonderful job. I love this. I love this job.
Scott, what years are these? Are these, we're talking late 90s by this point in time, or 2005, 2010?
Yeah, so I started there. GeoVista Center, I started in about 2005, 2004, 2005. Spent about 15 years there. Also in the process, so that was great because it was the GeoVista Center was multidisciplinary. So we were based in geography, but then we had so many collaborators from next door to us was the College of Information Sciences Technology. We had computer engineering collaborators. We had landscape architecture collaborators, sociology collaborators. Even towards the end, a lot of folks who were handling some of the big data. We had a kind of a umbrella organization called, what was it? ICDS. What is it? Basically, it was kind of a promoting big data, something data science.
Gotcha.
I forget. So we had it was an amazing experience. I learned so much. I was really blessed to be around so many smart people with so many creative ideas.
So 15 years of research in the mapping and the geospatial world, that's a phenomenal length of time. You said research as well as teams coming in. Your background at Esri must have given you a front row seat to here, Scott, can you wrangle this data? Can you display this? Were you sort of pushing technical boundaries or were you pushing customer questions? Were you sort of trying to go into uncharted territory, and I mean that in a bad way with maps, or were you trying to actually do larger data sets and get ready for a more public mapping world?
Yeah, so basically all of the above, I'd say. It was like, and you mentioned about sort of my experience at Esri, and it was kind of like once I came, it was like, so we had this really fascinating project. It was the very first project I worked on. This was, keep in mind again, this was like maybe 2005 or something like this. So we had this, we were doing a collaboration. It was NSF funded, but then we were doing a collaboration with Port Authority of New York, New Jersey for like crisis, managing large scale crises. They basically handle all of the security for the area, the New York metropolitan area. So then we were building this system where it's a large screen display. And at that time, we had this camera that recorded people's gestures and speech. And basically, you would point to this large screen display and you'd say, something like, there is an event here. Please, draw me a buffer around this point, this area here. And so it was really kind of fascinating that basically when I came in, boom, right away, I'm kind of like building the mapping interface for this. So it was really kind of cool. It was just right now, like large language models, super popular, right? Everybody's talking about it. So it's really kind of interesting how it reminds me of the missing part of that particular project. So back then, so the speech recognition was really crude at the time, and also too, like you would have to use really precise words, and then once you would say something, it would recognize the speech, and it would kind of just like, we had a whole bunch of like sort of like if then else statements. If the person said this and this and this, then perform these actions.
You're almost saying code, like a go north, open this,
kind of like hard coded, yeah. But now I feel like with large language models, this can easily interpret now what kind of in natural language what you're trying to say, and it can even give the instructions on doing the command. Maybe the only missing part is like, kind of what people are working on now is connecting that large language model to action, performing functions. So anyways, I'm telling this story, but so I don't know if this answered your whole question. But basically then to summarize the way I felt about this research was, we had our funding agencies coming, the various funding agencies, like we had NSF, National Geospatial Intelligence Agency, DHS. We had a project for Centers for Disease Control and Prevention, CDC. And basically they'd kind of like have their problem. And it was kind of like our job to try to figure solutions for their problem. So it was like really super like, stimulating. And I loved I loved all the meetings with, so once again, like I was really blessed to be around some super smart people at the time. So I learned a whole lot.
Absolute joy to be on the leading edge. I mean, to be in a place where that was the question being fired at you, every alternate week would be quite phenomenal. Can you look back at that? I mean, 15 years is a long time. The gold watch comes at 10 years. I see a gold watch on your wrist right now, but that's okay. 15 years is a lengthy bit of time where you've not only cemented yourself as being an expert in your subfield, but that whole team must have just been a go-to for, I take it, bigger and bigger questions. Were you starting out with the vocabulary from the customers of, can we do this? Yes, we'll show you. But towards the end, it was like, how big a question can you ask? And were you taking larger and larger chunks and steps and going from regional to nation-based to what I'm assuming now is a worldwide view of some of these tasks?
Yeah, so this is an interesting question. So there was a couple of points about this. Is that so one is like, we're supposedly the experts. So for one, we're guiding them kind of in this is what we think we should do. And then you kind of pointed out at the end, kind kind of in a sense, one of the reasons I fit in well there was I had a lot of experience with web programming at the time. And that basically, and then in the process, I learned databases. I learned, we had projects where we're collecting millions of tweets at a time. So I learned all this stuff about how to handle big data. So I was pretty good at then scaling up the projects. So, okay, we're going to first focus on a particular area, but then, okay, now we want to scale it worldwide. So this was, something. But then, and then another point to this is, you were saying about how far do you go? So this is like another, it's when you do science, you always got to be really kind of careful, because the more you do, and the more you're kind of bringing in much more variables. And then when you come to your conclusions, then it's a little bit harder to say with confidence that you've kind of done what you did. So this was always like throughout the process, it's always kind of like, okay, let's try to keep a focus on this. If we accomplish something else, it's cool, but try to keep a focus on the main problem, because this is the actual problem we're trying to address.
Yeah, gotcha. So there were bright shinies everywhere. You probably had a blackboard or a whiteboard of things you would like to tackle in the future, but every task you were being put forward, you would try and lock in most of those variables and just focus on the task at hand here, 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 and here, and take slow strides, but in looking back, large strides towards making maps, readily there for larger teams.
Yeah, and so this is, something like, it makes me, the way, the way you're talking, it makes me think of, it didn't always happen that way, because, for example, I mean, at that time I was doing a lot of coding, right? And now at this point in my career, obviously you want to code for a purpose, right? You want to solve an end goal. You want to solve an end real world goal a lot of times. But then it's kind of, nowadays, looking back, there was many times I kind of did stuff because I was like, this is really, really cool, but in the end, it didn't really serve that purpose, like an end goal. So, okay, this is really cool to do, but we really need to keep focused on what's our end goal? What is the problem, the real world problem we're trying to solve? And so this is another thing, like in the process of, while I was a researcher there, I mentioned that we were based in the geography department, but then we had collaborators from next door, which is the Information Sciences and Technology. Now, I think it's still called the College of Information Sciences and Technology. It's multidisciplinary itself. My degree is actually in informatics. It's multidisciplinary itself. But one thing I really, really liked about them, they were focused on using technology to solve real world problems. So this is something it was really ingrained in me, even too in my PhD, is you really got to keep a focus on, who's your audience? What is the problem you're trying to solve? How is it going to benefit them? How is it going to benefit society? So,
yeah, I think especially in geospatial, there's a tendency to be very technology driven. So I've seen it referred to as like the geospatial product trap, where, people build cool applications and do cool things with the technology, but is not really addressing a real world problem. And so then you've got this tool, or you've got this application, and you realize no one actually needs it because it wasn't actually problem driven, it was technology driven. And I like how you really come from that other angle, Scott, which is a breath of fresh air, especially in this like heavy technology field that you're operating in with the AI and the geospatial. But you're saying, hey, let's not be driven by the capabilities of the technology. Let's be driven by the problems that we can solve. And I think that's a really powerful position, and it's a really position where you're going to be able to help so many more people than if you just kind of get hung up in like the technology and think like, this is all the cool stuff that I can do and I can do anything for anyone, but then it's not really actually focusing on anyone's problem in particular. So I know you've been working a lot in the health field. I don't know, do you want to get into that a little bit and tell us how the story continues from after your time at the GeoVista, was it, to what you're kind of doing now, and more kind of how you're bringing together these different backgrounds that you've got, like the applied research strain and the geospatial strain and the AI, and how you're weaving all of that together. I'd love to hear a bit more about that.
Yeah, certainly. So like I said, I really loved my time at Penn State. So many nice memories, so many great colleagues that I still keep in touch with. Some amazing people. Maybe I should mention actually some names. I don't know if any of y'all have ever heard of Alan McEachran. I mean, he was basically my mentor. And one thing so there was lots of things I loved about Alan, but one thing in particular, so he began his career as a cartographer. He got his bachelor's, master's, PhD in cartography, and then he became one of the world's leading figures in cartography. But then as he progressed in his career, technology started improving, and he just really, he was a lifelong learner, which is something I took from him. I took it to heart, really. And I feel like I've kind of done this in my career. My career as well, is like, whatever the technology comes, I learn it. So despite the fact that he really, we would be in meetings and he's talking about these programming concepts, he's talking about these database issues. And then towards the end of his career, he even became so qualified that he became an adjunct, like I said, at the neighboring, College of Information and Sciences and Technology. So, anyways, maybe another guy, a couple other people. Anthony Robinson, he's an amazing guy. He's head of their now the Penn State online. He's not only is a professor but online learning. Was it masters in GIS for online program, and then Brian Tomaszewski, another. I feel like I don't know. Maybe I shouldn't have named names because now there's so many I'm going to leave out. Anyways, I can't forget about my advisor. Actually, I can't forget about my advisor for my PhD, Prasenjit Mitra. So this is kind of another thing. He came from the opposite way. So his degrees were in computer science. He got his PhD from Stanford in either computer science or computer engineering. Complete, what do you say, like a tech geek. And then he worked for Oracle for a while. But then he came from the other perspective that then he learned so much about some of these geospatial issues, and now he's like writing papers and all about geospatial problems. So this is what I was telling you about. This multidisciplinary environment was really wonderful. So anyways, okay, so I left there with mixed emotions. I basically left there to marry my now wife, and hence why I'm in Kuwait. So I left there with mixed emotions, but basically, like, this environment really set me up that now I just want to continue, like, challenging myself, trying to solve real world problems. So, Helena, you mentioned, sort of like health, technology towards health. So there was two, maybe even three projects while I was at the GeoVista Center. So we had one for the centers, the CDC, Centers for Disease Control and Prevention. So this was kind of like, we built for them both the Pennsylvania Cancer Atlas and in turn it was like the U.S. Cancer Atlas. We modified it, U.S. Cancer Atlas. So this was like an online AB. I mentioned to you about the action script in Flash. So this was built in Flash and action script. This was that time. But basically, it's like a whole bunch of like how do you present the data, like like amounts of cancer rates, but then all of the demographic data. How do you present it in a way to a user that they can understand it, they can filter it, they can search it, and try to gain knowledge from the visualization. Then we had another one. It was called Health GeoJunction. So this was taking large amounts of online media, news articles. So basically, like news articles, extracting place mentions, key topics. What are the topics? And trying to then map. So doing some geoparsing, basically. So extract the place names, put those place names on a map, and then providing once again a visual analytics system to let people visualize where are the diseases happening? Where are the connections going on between various diseases? The place mentions that are co-occurring. And then finally, too, there's one other. So a project I worked on for quite a long time. It was called SensePlace 2, SensePlace 3. So this was a really interesting part. It was really successful. We won this award for for a paper from IEEE. We wrote a paper. It was amazing that we got everybody, all of the team were kind of like, because it was it was called the Test of Time Award. So it was like 10 years since we wrote this paper, about our research. It was kind of like, whoa, I can't believe it's been 10 years. But basically, this project, it was kind of like it stood the test of time. Like it gets cited a lot. It generated a lot of discussion. So it was about kind of a similar concept about analyzing text. So at that time, Twitter was getting really, really popular for things like, people would talk about all of their societal problems on Twitter. So we built a system that, once again, it was really designed to extract meaning from this, incredible amount of Twitter data you would get. So the system was really not, we focused on crisis management, but then really it could apply to almost any domain. It could even apply to businesses these days. Like a large business wants to analyze, okay, our customers in this area, how are they responding to our products? How are they responding to our competitors? Things like this. So it was kind of interesting. So basically, given my background, multiple projects focused on health, basically technology towards public health, improving public health outcomes. So then recently too, I got a project. I was working with the World Health Organization. So this was once again, this was some folks based in the Afro office. So in Brazzaville, Congo, is the regional office. So basically, their domain is the vast majority of the African continent, excluding some of the countries in the north, excluding Egypt, Libya, a couple of countries. So they had this data set. I forget exactly but basically it's
acronyms.
Case counts.
Oof, always.
Yeah, it's comprehensive. Comprehensive. So when you hear data scientists saying good data, you really need good data, they had good data. So this was a really good thing. So it's basically suspected case counts and death counts for almost all of the diseases that the infectious diseases that go on in the continent for every week and for every district. So right. not at the country level, not at the state level, but at the district level, kind of the equivalent of a U.S. county. And so first we did some exploratory analysis, and we did some spatial autocorrelation. We saw one thing was we were able to find different. All of them had strong spatial correlation. So it's not really it's not hard to kind of think about this that if you have cases in your neighboring district, it's good chance it's going to affect you. So but what we were able to do too is kind of quantify it. So for the different diseases, there was a different amount, and so we're kind of quantifying it, quantifying the differences for the diseases. But then also too, after you do this, you get to local spatial autocorrelation. So this is when you're getting your hot spots, your cold spots, your outliers. So if you've got a cold spot, but then you've got a high district among them. So it was really, really, really neat kind of work. I don't want to talk about this too much because we got a paper. Hopefully that will.
Okay. Well,
hopefully it'll be published soon.
That's fair. We can't talk about something that hasn't quite hit the airwaves yet. But just to roll back a second, so everyone knows the last few years the dreaded R value. The COVID years have taught us to watch that number like a hawk. Was this research actually trying to correlate not the virology, anyway, how bad the viruses were, but the speed and the density, and trying to actually put time and space to that R value? Was that kind of the focus of that research?
So one focus was the spatial distribution patterns. and the factors that we chose to model. So, for example, we chose precipitation, temperature, population density. There's a couple other ones, and mainly because, like, for one, what is the population near a water body? Because water bodies are very important for disease transmission, either directly or indirectly. So then, what are the most important factors for the various disease, for the spread of the diseases? So what are the most important factors? And then the other thing is making a prediction. So making a prediction on cases. So based upon these criteria, these factors, precipitation, temperature, all of these, will your district have cases or not? So this was the other thing, basically making a prediction. So we were able to do really quite good. So with actually predicting, I'll have to be honest, with actually predicting the number of cases, we didn't do so well. So this is like if you're familiar with machine learning, this is kind of like it's called regression. So predicting the actual number of cases, it's a little challenging. And to be honest, too, I mean, we're doing this over obviously the African continent's vast, vast, so much variability. It's really not surprising. But when we turn this into a machine learning classification problem, are there cases or not? Then we started getting really good success. So this was, it's a little bit setting up the machine learning problem a little differently. Then we were able to get really good success. Basically in the goal of, so if you're able to predict cases or not, kind of like both at that local level, but over a large geographic scale, and on a weekly basis, and in a matter of milliseconds, then and you're successful at this, then it'll be really powerful.
That answers the question I was just going to ask. Was this work to actually try and get close to real time and be of use tomorrow, the next week? Or was this one of those deeper questions of, let's look at previous year's data and make broad sweeping recommendations for next year's possible viruses? Was it short, sharp, and in this case binary, or was it that long running question that you had time up your sleeve?
Yeah, so the model we built, I mean, it's more about the near term. I mean, so when you do machine learning and you create a model, I mean, you got to be really real. If you want that model to predict a long time in the future, I mean, our things change, our environment change, things like this. So you kind of got to update the model as you go. You got to retrain it and all. So basically, it was intended. The model that I built, it was like, say for example, if you have okay, next week it's going to be raining in this, rain prediction. You have all these variables. You have a prediction, then you'll be able to predict case counts. And basically, with a little bit more work, I wouldn't see any reason why it wouldn't be successful like a month in advance, 2 months in advance.
It feels like the global weather forecasting trend. By means, every nation has their own body that looks at the next 5 days, 7 days. There is a growing trend of worldwide weather models. And look, they're not always better, but sometimes they are surprising. But it's just that concept of extrapolating up from a large area to the world used to be impossible. We definitely won't be doing that, but that's now becoming potentially tangible. So once you've got a graph database, a chart of the whole world, potentially one day there might be someone down the track who decides, hey, let's just go for broke and do the whole world in one fell swoop.
Yeah. So you touched upon the value of our work. I mean, it's not like we were really doing, it's not like what we were doing, I mean, was really groundbreaking in itself to predict disease, but the fact that you could do it at scale and in fractions of a second, I mean, this is what's really the kind of like the key point to it. And it's not just simply like a prediction. It's not just, oh, we're going to predict this, but what you can then do is give a prediction, but do some modeling.
Just to clarify a little bit, Scott, because I guess not everyone listening to the podcast come from the geospatial background. Since we've kind of got also the scale on a different scale when we're talking about the indoor navigation robotics, the architect co-host, and so on. So, from a geospatial perspective, we've obviously got those different data layers that you're talking about. We've got the geography, so we've got the water bodies, and we've got the the human factors. We've got the different populations, and we've got the layers with the education levels. So we've got all these different layers that we're layering on top of each other for a typical geospatial analysis. And then you're bringing in the AI component. So can you explain a little bit maybe about where kind of geospatial starts and ends and the AI takes over? Like, is it that you're basically, you're modeling the as is with typical geospatial methods, and then the machine learning AI does the predicting, or is there not a clean cut like that? Or how do they play together to go beyond what's possible with pure geospatial capabilities?
Yeah. So this is an excellent question. I'll kind of talk about a little bit about the current state, but then I'll kind of mention where at least some people think things are going. So right now, I mean, most of the when we do geo AI, we love to stick on this geo in front of everything. So I guess maybe it's lack of better term, geo AI.
Guilty.
I don't really like it, but I don't know what else to call it. But in the end, the AI. So the AI model is the same as everybody else. We're using RNNs, CNNs, all of this stuff. It's all the same. Also, too, for some of the challenges like computer vision, doing machine learning on satellite imagery, it's basically some of the same models that you're going to do computer vision on regular pictures. Really, not too different. So I'll kind of comment about the project. This particular recent project is. So for the geospatial part, I used a lot of the geospatial part for pre-processing. For one, the spatial autocorrelation, the spatial hotspot analysis, to be honest, that did lead into us choosing some of the factors, that we did choose. Also, too, for example, I mentioned what's the population near water bodies. So that I kind of did some of the your standard wayback buffers and overlaying, getting the precipitation, but then bringing in the water bodies from OpenStreetMap, doing a buffer around them, and making some calculations. In the end, though, all of this sort of geospatial processing, in the end, I had kind of like a structured table. The result of this was a structured table. So I had, so it's basically for every district for every week, we had the number of cases, the amount of the average precipitation, the average temperature. So it's basically a Excel table, kind of in a sense. And so then the AI came in. I treated it basically as a tabular type AI model. So one thing I also considered, but we weren't able. I didn't try this. I wanted to try this. I treated this particular problem as, like I said, trying to get things into a structured table, treated as that type of machine learning problem. But in my mind, if some of the data, it went down to the disease data, the actual disease data. This was aggregated by district. However, in my mind, if we had a little bit finer spatial resolution, similar to the temperature data sets, precipitation, this was basically from your NASA, satellites, remotely sensed data. If we had the case counts, but on this kind of resolution or similar, then you could actually treat it as a computer vision problem. So this is kind of I'm trying to describe for this particular project how the geospatial and AI fit in. Now, kind of for the future, So I've heard a lot of talk in the kind of like geospatial geo AI is getting like AI models that inherently know space. So for my, once again, my particular case, in the end, this structured table, it really, maybe the model could learn this particular district is near this, but it wasn't very clear. If I would have treated it as a computer vision issue, a computer vision problem, maybe it would have been a little bit more spatial, where the model's able to know the pixels around it and all. But I think where some of the AI models are going is being able to inherently know the geographic relationships, not only nearness, but some of the other geographic relationships that all of the people in geospatial, like going back to like what is it, the first law of geography, which is even for this WHO project, it was really it applied when I told you about the spatial autocorrelation, is that paraphrasing the first law of geography is that everything is related to everything else in the world, but near things are more related to you. And so if we have AI models that kind of like account for this natural, then I feel like they'll be able to solve a lot of problems.
So doing it the way you were using the GIS world to prepare your data for a regular 2D data set, and that gave you the results and the tools and the levers for your clients to pull to be able to test and use different scenarios. And that was, what could you call that, a good 90-something%? Excuse me, a 90-something% answer, which gave people confidence, the ability to play. You're thinking ahead to different modes, different ways to increase, one more signal level, one more level of confidence in a data set to incorporate richer data, more variables. Is that all on the drawing board? Is it a wish list? Is it you're going to pass the can to someone else in 10, 20 years and they're going to solve it? How soon can you see these sort of problems going from that regional level down to the next level of cell?
And another thing, just too, like which was valuable from this machine learning. Machine learning, many of the models, they produce what's called a feature importance. So how important was that particular factor into making its prediction? So this was another thing that we were kind of. So it's basically, you got to keep in mind that this was for the machine learning model, not necessarily the real world, but it gives you really, really good hints at what are the most important factors for making that, out of like rainfall, temperature. It gives you it quantifies the importance. So that once again gives you a lot of information on a lot more knowledge on what do you try to tackle. What are the factors you really try to address first.
I'm also really curious, Scott, about how soon you think that, the geospatial, or the AI model that knows space or that understands geographic space, how far away is that, would you say?
Go on, make a prediction. This will be bold on the post. No, please.
No, I'm not going to pin myself to any. I don't know, the way things are going. All I can say is probably faster than I think, actually.
And what problems still need to be solved for that to become a reality? So I know we've talked on the podcast in the past about like the issues with AI and space in general, but like in the context of the geographic space, I would think there's a lot of specific rule sets and so on. But what are the hurdles that remain until there's a model that can actually do that? What's kind of the big missing piece?
To be honest, I don't know. I don't feel like I can answer that question. Maybe I would have. So basically, I feel like this might be a question for. So while I was at Penn State, I was also around some experts in what you say, like spatial cognition. So basically, how do people think spatially? How do people understand their place, where they're located? Things like directions, wayfinding, things like this. So I would say you get those people and you let them talk to the actual people building the algorithms, and then you can find sort of the missing piece, maybe.
Yeah, it's a really hard one, isn't it? I mean, I know I focused a little bit in my research about formalizing place, as in like how humans experience space, being like places. We don't think in coordinates. We think in terms of places. We think in terms of neighborhoods. We think in terms of, kind of personal reference spaces. And that's really an incredibly hard concept to turn into zeros and ones as you need it to be able to kind of teach it to a GIS system, for example. So it's, I guess it's just one of those big problems where personally I always thought, without knowing so much about how the AI works in that sense, that potentially large language models might give us a new avenue to explore that concept. You mentioned before with the Twitter, the sentiment analysis. I don't know if that kind of large scale language analysis of place sentiment could potentially be an avenue that would help formalize the concept. I don't know. Do you have thoughts on that?
Yeah, I mean, yeah, you're really. So like I said, one gentleman, Alex Klippel, I think now he's at a university in Germany. He was originally from Germany. He was my colleague for a long time at Penn State. Now he's back in Germany. I think now, though, he's kind of like getting into virtual reality. But he had a lot of this, kind of like what is place. Also, too, some other folks that came through. Brian Tomaszewski. Now he's at Rochester Institute of Technology. So when exactly this. When we were doing this sense place, basically that's the name. Actually, the name kind of came about. Actually, Brian Tomaszewski was the one who kind of coined it. Sense Place, and then he did Sense Place 1, and then we, together with us. But then it was like then we built Sense Place 2, Sense Place 3. But it's kind of like we had this. That was one of the overarching things. I'm not sure we ever really kind of like answered any questions towards that. But this was one thing: is that if you get a whole lot of text and people are talking about places, they're talking about other things. And you're starting to get in natural language processing, sentiment analysis, emotion analysis, some of the other natural language processing concepts. People mentions, named entity recognition. So people mentions, disease mentions, whatever the named entity is. We always kind of like had in the back of our minds, this is a really good opportunity to kind of like try to conceptualize exactly what you're talking about. How do people define place? And also too, like, we mentioned this earlier, a lot of the research in this area is at a really, really fine level, like doing things like user studies, a really narrow population, but can you scale this up? So can you scale this to the world, some of those ideas? So this was something, we talked about it a lot. I'm not sure we really kind of, tackled it directly, but that's in my mind, this is a really good, opportunity to use big data to try to understand how people actually conceptualize place.
Yeah, absolutely. I agree. And I think it's also interesting that you mentioned like scaling it out to like a world level. I think that there's a whole lot of other issues wrapped up in there that, possibly people don't really think about, like the different kind of cultural impacts of language. I don't know, perhaps, you're living in a different culture. I'm sure you've observed that people talk about things quite differently in different cultures, like places. The concept of place is very different across different cultures. And so what happens when we analyze these, big kind of English texts is quite easily that we kind of paint a very Anglo-centric worldview of what place looks like without really kind of recognizing that cultural nuance. And I think there's always that danger, and so potentially with like this kind of large scale analysis would even have to look across different languages, across different cultures, and really create something that brings in more than just the English. I don't know if that makes sense.
Yeah, it reminds me of another project we had So this particular project was focused on wayfinding, and actually, I think Alex Klippel was on this project, so he was really interested in wayfinding. So how do people follow? How do people get to where they want to be? How do they, kind of like do it in their minds? So for example, in the U.S., we have our MapQuest route directions, and it says go on this street, take a right, go down this distance, then take a right. Sometimes we use landmarks, but then like I said, Prasanjit Mitra was on this project. He's originally from India. He's like, yeah, we kind of don't do that there. He's kind of like, it's all about landmarks. It's all about landmarks there. So your how people, even for a task like this is just a small example, small part of place wayfinding, is extremely different depending on where you live in the world. In Kuwait too, they don't have they have street addresses, but honestly they don't use them much. So they have actually it's really I like their address system. It's really kind of intuitive. So they have, although honestly it's a small country, so it's a little bit easier to manage. But basically they have they have Kuwait City, the areas. So Kuwait City, the different kind of suburbs, Kayfan, Khaldea. But so basically you say, you would say something like, I live in Kayfan, and then Kayfan is divided up into block. Every area is divided up into block. So I live in Kayfan, I live in block 2, and I live on street 64, and I live in house 2. So this is how to say your address, kind of. You wouldn't say it kind of like a U.S. way, but honestly too, it's really it's and then they street signs in all of the areas you draw, and there's a sign with a little map on it. You're drawing on this road, block 2, and here's block 1. So it's kind of like they did a pretty good job with that. They laid out the roads too, actually, the highway system really well, because it's kind of like you got Kuwait City, you got first ring road, then you got second ring road, then you got third ring road, and it kind of just goes out. And then also too, you've got like these spoke highways going out, which is like, what is it, 30, 40, 45, 50. It's really kind of intuitive. But all of this kind of stuff is like, it's like you said, it's like really, really different depending on where you are in the world. And one thing I myself learned from my really, really smart colleagues at Penn State was everybody can see place differently. Like there's so much variability in how you kind of like, are you a spatial person? Are you not? I gave that example before about like if I don't know the direction I'm facing, I feel like uneasy because I'm a very, very spatial person. I used to play a lot of, and I remember playing one particular golf course where there was like trail around, very windy, through the trees, and you couldn't see the others. A lot of times you can see the other holes, but you couldn't. And this was, I never played it before, and there was I didn't know what direction facing, and really uneasy the whole direction. Yeah. I felt was really kind of like something's off here because I don't know where I am. I always like to know where I am and what direction I'm, which I feel like I'm really good at. When I hear my father-in-law, he's like, how is he even going to get around Kuwait City? He's from, but it's really no problem for me. So
very nice. Yes, Scott, I do share that same point of view, and I wonder actually if that's common or it's uncommon. Like I generally know which direction I'm facing vaguely, and it's really nice to be able to, if I'm ever riding or driving somewhere, going somewhere for the first time is a regular normal challenge. And the Melbourne thing is, which car lane do you have to be in 5Ks before you get there? That's our normal problem. But I'm always fine the second time, which is always a nice sort of vibe. But I must give a shout out to my cousins who were sailors. I can tell you right now I'm kind of facing south, but my cousins were crazy wild. They knew they were facing south-southwest. And it's like, okay, that's a level of distinction there.
Yeah.
Is a superpower that you need to try and find a use for. But yeah.
Back for Google Maps is like kind of actually when I moved to Kuwait now, I'm much more so reliant on Google Maps. But it was like before, it was like once I drive somewhere, boom, I know it. I would graduate school in South Carolina, and then once I drove from Pennsylvania to South Carolina, no problem. I'm going to drive 10 hours. I don't even need to, no directions. I know where I'm going, all of basically the turns. But now with Google Maps, that I'm following Google Maps, I feel like it's taking me longer to know the route, and I'm using maps longer until I actually know the route to go places. So I feel like I'm a little bit too reliant on the technology, maybe.
Yeah, that definitely happens.
Scott, thank you so much for your time. Absolute pleasure to have this long chat with you. It's been fantastic. Look, your application for unpaid intern at Spatial has been accepted, but we'll have to get back to you whether you can fill the role. But thanks to that, your qualifications are just passable. We'll get back to be honest, your success.
I love talking about this kind of stuff. I love talking about this kind of stuff, and also too. I mean, I love that you're doing. I mean, you kind of touched upon you're kind of a little bit more focused on the spatial part, versus I'm a little bit more spatial. But honestly, I feel like what you're doing here with spatial, combined technology, combined with AI. I mean, I love talking about this kind of stuff. So, and also too, another one of my what you say, like you said about something like a touch controversial earlier, something like this. This is one of my slightly controversial things, is that I feel like in the geospatial world, we play up the importance of the geospatial part a little bit too much, I feel. Because I feel like so many of the problems could actually be solved if you treat it as Cartesian space. Instead of like having to deal with the curvature of the Earth, all of this stuff. I feel like maybe this is something like the geospatial people, they want to think, sometimes a little bit more, and a lot, don't get me wrong, in a lot of cases is really, really important, but sometimes
for sure. There's always the purists versus the pragmatics.
Yeah.
And then there's always the spatial is special, isn't it?
Yeah.
You guys heard that? The spatial is special. It's
spatial is special.
Bit of a geospatial thing.
I remember when Google Maps came along, and I was in geography department and all, and oh my God, how could they possibly use Mercator project? Oh my gosh, I mean, I understand Mercator projection has its problems, but because they were able to treat the world as XI, they were able to do so many amazing things because they simplified the problem, and then they were able to do some amazing things. So this is kind of just one example, I feel like.
And the vast majority of Google Maps users probably don't even know. Yeah, it does. So I think most users of Google Maps, they have no idea about projections anyway. So it's really kind of, back to what we were saying before, it's solve a problem for your user, and they don't care about, projections. That needs to be abstracted under the hood, which Google Maps has done a fantastic job of. So solve a problem instead of...
Most of the time when you're using Google Maps, I mean, you're looking kind of like local. So you're not really even going to notice the difference. So I hope I didn't upset any of my former colleagues when I made that comment.
I tell my teams all the time that there's no Oscars or Emmys for coding. Yes, there probably are a couple of awards in deep, dark places on the internet. That's not to be a cop-out. But if it works and it's reliable and you can sleep at night and it's elegant, simple and does the job done. There's no need we can solve some gnarly problems with a lot of code, and as long as we're okay with it, that is the job. So it's great to hear that pragmatic sense coming through.
Yeah, you and I talked about this a little bit yesterday, and both of us kind of like having coding in our background. It's like no matter what, you're going to have some issues. So you kind of got to like pick your battles. So what are the really, really major problems? And okay, this I'm able to sacrifice. Am I able to sacrifice speed? Am I able to sacrifice something just isn't quite, but I'm able to solve a bigger problem.
Brilliant. Well, Scott, thank you so much for your time. We're going to stay in touch, and by all means, we're going to come back when that paper of yours is announced and ask a few more questions about it, if that's all right.
These reviewers, they're killing me.
I know, we're leaving the audience hanging. Come back for the next exciting conclusion of will Scott be able to talk about his forthcoming paper? Look,
Yeah,
thank you
thank
so
you,
much.
Adi.
You
Thank you,
have a
Helena.
great evening.
Wonderful talk.
Absolute pleasure to chat to you.
Enjoyed it.
Lovely. Take care all, and we'll catch you on the next episode of Spatial. Bye, team.
All right.
Bye.
Yes, bye.
Masalama.
If you'd like more news and insights about spatial AI, or have a story or interesting topic you'd like us to cover, reach out to us. Or better yet, come and join the community at Spatial. All the links are in the show notes.